We are doing the road less traveled. We are in module 3. We are on topic 2. This is on page 61. You should do this warm-up that is right here. Now, if I look at this warm-up, and I'm going to graph this, I would look at this first one and I would say my slope is this invisible 1 that's right here. And my y-intercept is 0, 0. So I would do that. I would go up 1 over 1, up 1 over 1, up 1 over 1, over 1, 1 over 1, up 1 over 1. And go like so. Or I could have gone down 1 over 1. Either way. And as I do that, I don't need that many points. And I would draw a line, making sure that I go all the way through the coordinate plane and I put arrows on it. The other one, and remember, that's invisible right there, has a slope of -1. It also is going through the point 0, 0. So I go to 0, 0. And instead of going up 1 and to the right 1, I'm going to go up and to the left. Up and to the left, up, left, up, left. Now, if I had decided to go down instead, I would have gone down and to the right, down to the right, down to the right. And again, I don't need every single point. Yes, I like to keep going. I got a little off there, but that's okay. Okay, so what are the coordinates of the point of intersection? So where do they run into each other? I'm really hoping that you noticed that they ran into each other right here at the point 0, 0. Okay, what does it mean? Oops, sorry. This intersection means that that is where, right there, is where they both have the exact same solution. They have the same solution. Okay, awesome. Okay, let's go to the next page. Okay, so many of the diagonal roads in Washington, D.C. are named after U.S. states. Remember, diagonal is this way or this way, okay? Except for California and Ohio, every state provides the name for an avenue. California is actually a street. Ohio is a drive. There is a Puerto Rico Avenue. So if I look at this, the ones going horizontal, we have C Street, we have B, look at B Constitution, same street. East Capitol, we have Independence and South B, those are exactly this, or so they're the same street. If I look at my vertical, I have First Street, I have Second Street, but my diagonals, I have Delaware, I have Maryland. Those are the only ones that are shown. There are bigger ones, or a bigger map, but these are the only ones we're using. So let's look down here. It says, answer each question and explain your reasoning according to the map shown. Would it be possible to meet a friend at the intersection? That means where they run into each other, First and Second Street. Well, look here. This is First Street. This is Second Street. Will these two lines, will those two streets ever intersect? It is not possible. The streets are parallel. They'll never run into each other. The streets are parallel. Okay. Would it be possible to meet a friend at the intersection of Delaware Avenue and Constitution Avenue? So let's go up here and look. Delaware's here, Constitution's here. They run into each other right here. So would you ever be able to meet somebody there? Yes. Because the streets intersect. And then, would it be possible to meet a friend at the intersection of C Street and 2nd Street? So 2nd Street is right here. Oops, sorry. 2nd Street is right here. C Street is right here. Yeah, right here. Don't they run into each other? So same reasoning as up here would go right there. The next one. How many places would you be if the intersection of Independence Avenue and South B? Well, look here. Aren't they the exact same street? So the whole thing is the same street. So how many places? Infinitely. Many places. Many places. Anywhere along that street, you could run into each other. Awesome. Okay, so let's go over to this next page. Let's talk about Colleen and Jimmy real quick. They both have part-time jobs after school. Both have decided that they want to see how much money they can save in one semester by placing part of their earnings each week into a savings account. Colleen currently has $120 in her account and plans to save $18 each week. Okay, so Colleen, we're going to be putting it into an equation that, I will go out a little bit. That looks like that. So remember, this is a rate. This right here is the rate by which something is going up. Okay, so for Colleen, her rate is 18 per week. And then she's going to put down where she started at. That's what the y-intercept is 120. Oh, we forgot to define our variables. I apologize for that. Oh, it says it right here. Okay. I didn't read the actual next question, so we'll go to that in just a second after I read this. Jimmy currently has $64 in his savings account and plans to save $25 each week. $25 each week. Okay. So it says write an equation for Colleen and Jimmy that represents the total money in dollars in each week. Okay. So Y so Y is the dollars. Okay. And the X is the weeks. So it's actually number of weeks. Okay. And this is money saved. That's what it really is. Okay, so now we need to do Jimmy. So Jimmy currently has $64. That's how much he already has in a savings account. So that's 64. He's going up $25 each week. So he would be 25x. How much money will each person have in his or her savings account after 5 weeks? So 5 weeks is the X value. So we're going to replace X with 5. So let's do it for Colleen first. So we have 18 times 5 plus 120. Okay, and so if I have 18 and I multiply it by 5, I'm going to get 90 plus 120. And that's going to get me to 10. So $210 is how much she would have. Then if I had Jimmy, I'm going to replace his X with 5 also. And when I do that, that would give me 125 plus 64. And that would be a 9. That would be an 8, 189, $189. Which person will have more money? So which of these two people would have more money after 5 weeks? Hopefully you notice that Colleen has more money. Oops, more money. I forgot the word. There we go. How much money will each person have in his or her savings account after 18 weeks? So we're doing the same thing, except for instead of using 5, we're going to put 18 in. So 18 times 18 plus 120. 324 plus 120. And that's going to equal 444. Then I take 25x plus 64. So y equals 25 times 18. Oops. Plus 64. And I get 450 plus 64. That would be a 4. That would be a 1. 514. So now who has more money? Now after at the end of the time, doesn't Jimmy actually have more money? Okay. Who saves more money per week? Well, we could either look at the equations or we could look just at the sentences. We look at the slope. Whose slope is bigger? Jimmy's slope is bigger. Well, if we look at the words, Colleen is saving 18 each week. Jimmy is saving 25 each week. 25. Jimmy's still the same person. So Jimmy. How can you tell who is saving more money each week? By analyzing. Oh, sorry about that. We skipped this whole part. So we're going to create a graph. Okay. Let's look down here. Well, we know we have to get 18 weeks on here. We could probably go up by 1, 2. I'm just going to do this. 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so variable quantity. So we're talking about the number of weeks. They're starting at 0. The upper bound is 20 because that's what we got to right here. And we're going up by 1s. Oh, I should be doing this in a different color. Sorry about that. Then this would be the savings. We're obviously going to start at 0. We have 20 of those. If I go up by 20s, that would get me to 400, but we need it to go a little higher than 400. So what if I go up by 30s? So this would be 30, 60, 90, 120, 150, 180, 210, 240. Sorry, you can't really see it in there. 270, 300, 330, 360, 390, 420, 450, 480. Sorry, we're getting closer and closer together. 510, 540, 570, and 600. There we go. So we went up by 30s and we got up to 600. Okay, so now we're going to graph this. So Colleen, her equation was y equals 18x plus 120. So we start at 120. So 120 is right here. And I'm supposed to go up 18 and over 1. Well, that's a little more difficult. But don't we know from the other side of this sheet of paper, didn't we do 5 weeks? So 5 weeks for her was 210. So 5 weeks for her is 210. So I'm going to do 5, 210. And then we know for 18, it's 444. So 18 is somewhere about here. Okay, so then draw our line. And no, it's not going to be perfect, but we're going to do the best we can. Oh, yep, that dot should have been up there. That's my fault. And then Jimmy, he was, what was he? I could just turn it over. 25x plus 64. So he started at 64. Well, that's about what right there? And at 5 weeks, he was 189. 189. So there's 180. So about right there. And he was 514 at 18 weeks. 514. Let's see if I can do this better this time. 514. Somewhere up there. Okay. Determine the number of weeks after which Colleen and Jimmy have the same amount in their banking account or in the savings account. Well, now it's not going to be perfect, boys and girls, because my lines aren't perfect and whatever. So somewhere in here, so I'm like right in the middle here is 10. So are we going to guess 10? 10 weeks? That's what I'm going to guess. Oops, I should have used a different color, but that's okay. We're going to verify it. So y equals, and I'm going to, oops, I'll go ahead and do Jimmy first. We'll do 10 weeks plus 64. So that would be 250 plus 64. So that would get me, that's a 4, that's a 1, that's a 314. Did I do that right? I think so. Let's look at Colleen's. Okay, hers was 18 times 10 plus 120. So that would be, I think this is going to be off. This would be 180 plus 120, and that's going to get 300. Oh, so we're a little bit off. We're a little bit off. So maybe, let's see. Oops. I can't even. Maybe it's a little, well, so this still has, oh, look at this. This has the orange line is higher than the blue line. So at 10 weeks, this orange line is actually supposed to be higher than the blue line. So that means we need to go back. We need to go backwards a little bit. So I'm going to go back to 9, how about to 8 weeks? Is that, I'm going to go ahead and try 8 weeks and see if that works. So if I did 18 times 8, I would get 144 plus 120, and that would get me 264. That looks about right. And let's try it with the other one, with Jimmy. Let's try, I didn't mean to do that. 25 times 8 plus 64. That's 200. Oh, look at that. So it wasn't 10 weeks, it's actually 8 weeks. So if we're able to graph better, will come up with the exact number. That was my fault because I didn't do a very good job of graphing. They actually should have met right here. The meaning of the slope of each graph, and the thing is how much money they saved each week. Okay. Awesome. Now, I'm actually going to skip those parts. We're going to come right here and go over this. These are called systems of linear equations. What that means, that there are two or more linear equations that you're graphing on the same thing, or that you have written down. Okay, the solution of the linear system is the ordered pair that is the solution for both. And I'm going to underline that part and circle it and do everything both. It has to be a solution to both, not just one of them, but both of them. So if I look at this point where they run into each other, that has to be a solution for both of these equations. It can't just be for one, it has to be for both. Okay, we are going to go over to our discovery real quick. It should look like this right here. Sorry, I am trying to get to my next part. There we go. Okay, so we're going to do this. Systems of equations. Two or more equations with two or more variables. Answers will always be in form of the answer, or the solution will always be an ordered pair x, y. One way to solve the system is by graphing, and that's what we've been doing. There are three ways that you could get this. They cross, they never cross, or they're the exact same line. So here we go. I'm going to graph this right here. For my first one, my slope is the number sitting in front of x, so that's 2. My y-intercept is 0, -5. So I go to 0, -5. Remember, slope has to be rise over run, or the height over the width. It's positive, so it's going this direction. So I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And I draw a line. Sorry about that. And we have arrows on both ends. Then, this next one, the slope on this one is a -1/3. Remember, boys and girls, that's going this direction. It has a slope, or sorry, y-intercept of 2. So I go up to 2. I'll go up 1, but I have to go to the left 3 in order to get the correct direction. If I went down, I would then have to go to the right 3. Okay. And I draw my arrows. So, what's the solution? Where do they run into each other? Where do they run into each other? They run into each other right here at the point 3, 1. Okay, now I'm going to look at the slopes. Look at these two slopes. These two slopes. Are they the same or are they different? The slopes are different. Are the y-intercepts the same? No. But we're going to talk about this. If we have one solution, this has one solution, it runs into each other one time. I almost spelled it wrong. When the lines intersect, oh, I should just write intersects. They are only going to intersect once for one solution. Okay, on this one, the y-intercepts, they could actually be the same or different. Okay, so if there is one solution, the slopes are different, and the y-intercepts could be the same or they could be different. Okay, let's look at the next one. Let's look down here. My slope here is 3. It's positive, so it's going this direction. Y-intercept of 0, -1. So I go to 0, -1. I'm going to go up 1, 2, 3, and I need to go to the right because I need it to be positive. 1, 2, 3 to the right. I could have gone down 1, 2, 3, but I would have had to go to the left. So then I draw my line. That's not very good, but you can still see it. And this one, my slope, oh, look at that. They have the same slope. My y-intercept is 2. So I go up to 2. I go up 1, 2, 3. I go over 1. I go down 3. 1, 2, 3, over 1. 1, 2, 3, over 1. Now, if I had drawn this perfectly, you would have noticed that these lines are parallel. Okay? There is no solution to this when the lines are parallel. Anytime the lines are parallel, you will not have any intersection. Solution, no solution. And if I look at this, if I look at my slopes, they are the same. The y-intercepts are different. The slopes are the same, but the y-intercepts are different. Okay, let's go to the next side. Okay, right here, let's graph these. If I graph this one, my slope is 2, so that's positive, so I'm going this direction. My y-intercept is 0, -2. I go to 0, -2. My slope is 2, so I go up 2 over 1, up 2 over 1, up 2 over 1. Or I could have gone down 2 over 1 and had a positive slope of 2. Well, if I was to do the other one, if you notice, it's the exact same line. So I'm just actually going to go just on top of it because they have the same slope and the same y-intercept. So boys and girls, the solution to this is infinite. Just like when we were talking about, what was it, Constitution Street? Let's see, where was that? Just like when we were talking, oh, it's Independence Avenue and South B. They're the same line. Same thing as here. They are the same line. So there are infinite solutions. The slopes were exactly the same. The y-intercepts were exactly the same. So, in order to have infinite solutions, infinite, I don't know why I put an F on that, when the lines are the same. Okay, so what did I just say? So if there's one solution, slopes are different. Just think of that. Don't worry about the y-intercept for that one. The slopes are different. If I have no solution, okay, slopes are the same. Y-intercepts are different. And then last but certainly not least are infinite. given solutions. I couldn't put it in there. Okay? Slopes are the same. Y-intercept, again, same. So, knowing that information, if I have one that's one solution, and this is my equation I'm coming from, slopes have to be different. So I could do anything as long as my slope is not 3. So I'm going to put 2x minus 4. Or I could have put y equals negative x plus 5. Whatever. As long as the slopes are different. No solution. Okay? No solution means the slopes are the same. So the slope is 3, so that means this has to be 3. The y-intercept, though, has to be different. So plus 2. And last but certainly not least, infinite solutions, it's the exact same equation. So if I look at this down here, so which one has 1, which one has no, and which one has infinite? So the ones that have intersection, that has 1 solution. The one that is parallel, this is no solution. And the ones that the exact same line, this is infinite solutions. Okay? Now to do this last part, in order, remember we said when we were doing this that it has to be, if it's a solution, then it has to be a solution for both of the equations. Somewhere around here I highlighted that. Right here. It has to be a solution to both of them. So we have to prove that this is a solution to both of the equations. So if I have y equals negative 2x plus 3, this is my x value, this is my y value. I'll even zoom in a little. I'm going to replace my y value with 3. My x value with 0. Where did I come up with that? Right there. So 3 equals 0 plus 3. 3 equals 3. Does that work? It sure does. So now let's try it on the other equation. The other equation is y equals x plus 3. I replace the y value with 3, the x value with 0. 3 equals 3. It worked for both of them. And so it is a solution. So how could you tell? Plug in the ordered pair. That's how you would do it. So we're going to go back to the book real quick, and we're going to go to page 72. I'm going to go to page 72. If I can get there. Right here. Okay, and we need this information that we just had a minute ago. This right here. About the different solutions. Okay, so I'm going to look at this. I'm going to look at my slopes and I'm going to look at my y-intercepts. So if I look at my slopes, I have this slope and this slope. They are totally different. Slopes are different, slopes are the same, slopes are the same. So automatically the fact that the slopes are different, that means that there's one solution. Okay? Then, I don't know why I'll just do this color. Then I'm going to look at this one. Here's the slope here. Oh, well I have to multiply, oops, sorry. I have to multiply this through. So that would get me 4 over 6x plus 42 over 6. Simplify that. I get 2/3 x plus 7. Okay, So here's my slope. Sorry about that. Here's my slope right there. It's the exact same thing. So that means it has to be one of these two. Then my y-intercepts are exactly the same. These are the exact same equation. So that means that this is infinite solutions. Okay, so let's look at our next one. Here is my slope. Here is my slope. Those are exactly the same. So again, if they're exactly the same, it's going to be one of these two. My y-intercept is different though. So that means it's going to be no solution. No solution. And then last but certainly not least, my slopes are different. Automatically, if my slopes are different, I have one solution.